Hi, and welcome to this new round of ICIS interviews. My name is Ixchel Peyrot, and we are continuing this effort to get to know the infant research community around the globe. And today's interview features Dr. Abigail Fiske, who received a special recognition for her outstanding dissertation at the 2024 ICIS conference. Hi, Abigail, and thank you so much for taking the time. How are you today?
Hi, thank you so much for having me. I'm good, thank you. How are you?
Oh, thank you so much. So we would love to learn more about your dissertation, but first, could you give us a brief introduction about yourself and the research group you are part of?
Sure. I have recently started a lectureship in neuroscience at Lancaster University, in the United Kingdom. And I work as part of the Department of Psychology, working with the Infant and Child Development Lab at Lancaster, where we study the development of infants, toddlers, and young children. Before that, I just finished my PhD this time last year at the University of Oxford, where I was working in the Department of Experimental Psychology with my supervisors, Dr. Carla Holmboe and Professor Gaia Sheriff, where we were looking at the development of early executive function skills in babies and toddlers. So my dissertation for my PhD thesis was looking longitudinally, which means that we were following the same group of babies and families at several different time points across the early years of their development. Which was really exciting in itself because it meant that we were able to build quite a nice relationship and get to know some of our families and see the children as they grew up, which was really exciting. And the kind of aim of the research study was to understand more about how executive function skills, so kind of cognitive skills like memory, attention, inhibitory control, how they emerge in infancy and also how they change and progress as the children get older. So we were running this study with my supervisor, Carla Holmboe, and hoping to follow a group of about 200 children from when they were 10 months of age all the way to 2.5 years. Unfortunately, this all happened with the pandemic in the
Oh,
middle. Um, and so, unfortunately, because of the kind of lockdowns and the
yeah.
restrictions that were in place during that time, our lab closed for about 18 months, so a year and a half, which meant that whilst we'd started following our cohort of children in infancy and toddlerhood, we missed quite a large chunk of time. But to kind of come through the other side, we were able to follow up with our children when they were now 3.5 years old instead of 2.5 years old. So we could still look at their development over time. However, we did have that big gap in
Yeah.
the middle that we hadn't planned on. Ah, um, so that's just some kind of context, I guess, of the study and the big disruption that we had that wasn't
Yeah.
planned. And so I guess I can talk now about some of the methods and the findings as well.
Yeah, if you want to, go ahead.
So, my kind of role, I guess, in this bigger longitudinal study was to focus specifically on inhibitory control development. And that's the ability to kind of stop yourself from doing something that you either really want to do, that's become a habit for you, or something that's quite an automatic response. It's stopping that skill. And we used a task that was on a touch screen, like an iPad, called the Early Childhood Inhibitory Touchscreen Task, which my supervisor, Dr. Carla Holmboe, developed. And this means that we were able to measure response inhibition skills from as early as 10 months of age. And it was really great because the task can be scaled so that it's suitable across the early years of life, even into adulthood, which is great for longitudinal research where we can track development in that skill over time. And then alongside that task, I also was interested in understanding what's happening in the brain whilst children are having to inhibit.
Yeah.
And so I used a neuroimaging method called fNIRS, functional near infrared spectroscopy, which is a really great child-friendly method that uses a kind of light called near infrared light to help us understand more about the changes in hemoglobin in the brain.
Oh, wow. So what were like the main results or the main pattern that you found?
Yes, so we were really interested in what we would find because we weren't able to make any strong predictions because it wasn't something that had been done commonly before using this fNIRS technology with infants so young. So we were intrigued to see which areas of the brain would be involved when infants had to inhibit. And so what we found was that our youngest infants, so 10-month-olds, when they were inhibiting, they were using parts of the prefrontal cortex and parietal cortex, but only on the right side of their brain.
Mm.
Whereas when we saw the children again at 16 months of age, we actually didn't see any change in their ability to inhibit. So they were performing at the same sort of level as they were when they were 10-month-olds. But now we saw that they were using both sides of the brain and they were using slightly different areas of the prefrontal and parietal cortices. So that was really fascinating to see because we didn't see that change in behavior, but we saw some real clear differences in the brain. So
Yeah.
that was really, really exciting. Um,
Wow.
and then the final kind of finding, I guess, is that when we eventually saw the children again when they were 3.5 years after the pandemic, we used the same task again and the same fNIRS technology. And here we found, of course, now behavior has improved and the children are much better now. They're much older, but much better at inhibiting. We begin to see again this activation only on the right side.
Wow.
So it's a really interesting pattern. And we think that because in adult studies, much of the activation is also in the right hemisphere, we think that this could be kind of the start of a mature brain response at 3.5. So it's very exciting findings.
Wow, that's really amazing. I'm just curious about the task. So is it the same task during all the periods of assessment?
Yeah, thank you for asking. I didn't explain the task either, I realized. So it is it is a yes, it is the same task at each of our age points. And the task is designed that it doesn't really have any instructions and it's really simple. And that's because we need to be able to use it with babies
Yeah.
who are not going to be able to understand instructions or follow complicated rules. So the babies see basically two blue boxes on either side of the touchscreen, and one of them has a smiley face, which is like our target. And if they touch on the smiley face, they get like a nice cartoon and some sound effects, which they really enjoy. And we build up a response to a particular side of the screen. So maybe the smiley face appears on the right-hand side of the screen most often, so maybe on 75% of times. But then on 25% of time, suddenly the smiley face is on the other side of the screen. And so
Okay.
they've built up a response
Yeah.
to one side and they have to stop that response and respond on the other side. And we made that task accessible for the different ages across development by just tweaking small things. So we changed, for example, the length of the cartoon after each trial. We made it shorter for the older children so that the kind of pace increased. And
Yeah.
we also increased the number of trials that they were expected to complete, again, because they have longer attention spans and are able to engage for a little bit more. But it was really great that we could keep the task consistent so that
Mm,
we can be more confident that the changes that we're seeing are because of age-related
yeah.
change rather than switching different tasks. So that was really cool.
Yeah, that's really smart because I mean, when you are working with infants, is and of course, if you are working like longitudinally methods, it's really complicated and always like a debate about how are you gonna measure the same ability in different stages,
Right.
and but that's really smart. Like not involving also the instructions or language, right? Just one specific ability to measure.
Exactly. It was really simple. So this was all my supervisor, Dr. Carla Holmbo, fantastic development of this task that's been really well suitable for our population, so infants and toddlers and young children. And I think kind of as something to work on in the future, both in the field, but also something that I'm interested in doing is
Yeah,
kind of continuing to think about what tasks we can use to assess executive functions in, even the youngest infants, but also can we keep those tasks the same or what can we do to make those slight changes so that we can keep tasks quite consistent when we're looking longitudinally. So that's kind of something I'm hoping to continue to work on.
yeah, that's amazing. Well, where does your passion for conducting infant research come from? I mean, how did you decide to pursue a PhD?
That's such a great question. Yeah, so I mean, I'm sure everybody says this, but I think I've always had a passion for developmental psychology. Before I started my PhD, I was actually a primary school teacher. So I was working teaching children from the ages of 4 to 11 years old, so primary school age in the UK, and had my own classroom, and I really saw through those years of teaching experience in the classroom how diverse development is and what it can look like in different children and in different circumstances. And one of the key kind of things that stood out for me there, I guess, is about executive function skills and how that can, support children in certain ways, but how it can also could cause difficulties if children are struggling with executive function skills. And so I guess I was kind of really motivated to find out how these skills develop and what we can maybe do to support the development of these skills in early childhood before we get to school age. And so that really motivated me to kind of pursue my PhD. Where I was really lucky to work with some great supervisors at Oxford and be able to dive into this topic even more. And as I said, it was so great working with all of the lovely families who came and participated. And it was just so great working with babies in the lab. So, yeah.
Yeah, they are. It's really funny to work with them.
Yes, you never know what to expect and what you're
Yeah,
going to get. So it keeps you on your toes and you have to kind of adapt and yeah, but lots of fun, lots of giggles.
yeah. Do you have any advice for students interested in this field?
Advice, yes. That's another great question. Thank you. So I was thinking a little bit about where I was when I was, trying to start up in this field and thinking about research. And I think one of the biggest skills that I would suggest that students maybe try and get is things like experience, just being around babies and young children in different environments. I mean, maybe asking if you can shadow some research studies in a developmental lab at your university, or finding childcare settings and preschool environments where maybe you can go and volunteer just to get that experience and confidence working with different children and their families, and also understanding a little bit about what development looks like would be a really great place to start. And I also think it's a good piece of advice that in our sort of developmental community and in ICIS as well, the community is so collaborative and supportive. And I think that that should be encouraging for students to be able to go and introduce yourself and, say to somebody, I'm really interested in your research. Can you tell me about it? Or ask somebody a question, no matter how small, because
Yeah,
everybody would be very welcoming and happy to talk to you. So take that first step, for sure.
yeah, you have to dare sometimes.
Yeah. But I think
And
everybody would be so happy to hear from
yeah,
students. So,
yeah. And well, what do you enjoy doing when you are not conducting research?
oh, I love that you asked that question. What do we do outside of science?
Yeah.
So I actually really enjoy exploring, and that might sound really strange, but we've just recently moved to a new part of the country, and so
Oh,
it's really exciting to be
yeah.
able to kind of see what we have on the doorstep and find new places that we enjoy, maybe going for hikes or finding a new cafe. So
Mm.
that's been really fun at the moment. And I am really lucky because I now live quite close by to my sister, and she has two
Oh,
small children. So we get to
oh,
play a lot, and it's really fun watching them grow up. Yeah.
oh, that's really amazing to have like another life besides the lab.
Yeah, absolutely. And I'm really grateful that at Lancaster University we are encouraged to have such a great work-life balance so that we can kind of, be ourselves and enjoy life outside of the lab as well as inside the lab.
Yeah, that's always helpful too.
Yeah, very appreciated. Yeah.
So, thank you very much for being here today and for sharing your knowledge with the ICIS community. Take care and ta-ta.
Thank you so much for having me. It was great to speak to you and hopefully stay in touch in the future.
Yeah, totally.